will flow from non-quantum systems into quantum systems. With that, what is Nexus's roadmap? I see there's plans for tokenization of securities, delegated proof of stake, which you already explained. But what's next on the what's the last thing to achieve for Nexus before it becomes that mainstream thing, where it's the nexus of everything?
You need the file management and the remote login, and then the peer-to-peer relay system. That's really important too, because now you can securely transmit data between applications. You can basically do peer-to-peer chat. That's another really big one that's, I think, important, peer-to-peer messaging. And there's another one, somebody in the community is working on decentralized social media standard. He's almost done with it. He's just waiting on, a couple features from me that I'm developing. So that's use cases are driving a lot of those priorities. That's on the single dimensional blockchain aspect. But then we get to the multidimensional chaining and all that comes out, and, the Amin and then Obsidian. So, when I consider it done, ready for mainstream, it would be Obsidian. That creates like the decentralized mining pool, the multi-layer consensus, the multi-layer chaining too. Instead of just chaining in one direction, you're chaining in multiple dimensions, which allows you to create this three-dimensional block, basically that you could think of that as like, it's like all of the transactions are held on different nodes. It's like this large sharding system, but they all correlate back to this root cube. And you always have a Merkle path back to this root cube, so that this big giant block that could be 100 gigabytes, which you'll have if you have really, really large transaction volumes, it's storing that data more than processing it. That's the biggest problem, right? Like I was saying, a transaction, if it's a kilobyte and you're doing 1 million transactions a second, okay, now you've got that would be a gigabyte per second. Now you've got 86,400 seconds in a day. Now you've got 86 petabytes per day, just at 1 million transactions a second, right? It's just, sure, you can process that, but where are you going to put it? It's a big issue. So, the multidimensional chaining also creates data sharding with the lower level database architecture. That's, I think, what's really going to be important for mainstream adoption. We need to have the full multidimensional sharding systems. Ethereum gave up on sharding already because it's too hard. I get it. I understand. I've been thinking about this for a long time, and I've been seeing it, and I was like, your sharding's not going to work, guys. Plasma. They're like, no, it's going to drop Plasma, and then they're, chain of chains, and they drop that. And I spare you the details on why they'd run into these issues, but the architecture I've been developing, it'll work. And I've actually seen other people try to steal. I think Zilla Q stole some of it when they had a mining layer measuring and comparing against like a consensus layer, because you need to have multiple layers in a consensus, right, in order for it to be fully scalable. You can't just have this flat system. But then also the architecture of the transactions and dependence, right? If there's a dependent on another contract, you need to package that, but you can't package that if you have all these previous states that you need to have. But what's so cool about a SIG chain transaction is everything in that one transaction is everything you need. You have the state of the register that was modified. You have the operations. All you need is that one transaction and a Merkle proof to it to know that's the state you need. So if you need any extra states, you just package your extra states with that one that's operating on those states or reusing them as prerequisites, and boom, you don't have that sharding issue where one shard slows down another shard. And then the multidimensional chaining, that preserves it, makes it a lot harder to manipulate, because you're chaining across as well as you're chaining forward. So if you imagine like these fingers as your shards, you're chaining across each of these shards too, so that they become one object in a sense, kind of like a wafer you could see it as. And then that object is then added in with the L2 layer, and then the L3 layer acts kind of a mining pool where everybody submits shares. And so that all of that mining power is used instead of just the one that wins. Because in Bitcoin, the only computing power that actually goes towards network security is the miner that finds that hash, finds that winning hash. All the other miners, all that electricity they spend it's gone. It's just, you got to reset and start mining the next hash. So if we could capture all of that electricity, right, capture all of that mining power and focus that in, you're going to get a lot more secure mining system. Right. So that's the L3 layer. So that's when I say it'll be fully ready for mass adoption. I don't know when that'll be done. It's never been done, but we're going to stage it in. So, Tritium's the single dimensional chain. When we get to a mean, then you'll be able to, opt into a shard and be like, okay, I want to process my microtransactions on this shard, and you'll have 4 shards to start. so that you can, move your coins into there and process on the shard systems. And then the shards and their hashes will be processed like a transaction in a group on the Tritium block, but you still be able to process transactions through Tritium as well. So it's going to, transition people slowly that way. And then eventually Obsidian wraps that all up and puts a shiny little mining bow on it. So yeah, that's the full vision. And then, by that time as well, like having more satellite communication working, mesh network communication. That's another really important one where we can form local mesh networks and local nexuses, for, many other reasons than just one. Imagine if power grids fail or food grids fail or whatever. We'll need to be able to communicate with one another.